8.6 encompasses two types of equations: exponential equations, shown in yellow, and logarithmic equations, shown in green. Putting these together would be quite a lengthy lesson, so I thought it would be best if we split this 8.6 into two parts. So today we are going to look at exponential equations. Today we're going to solve exponential equations, and when this lesson is complete, you should know how to solve exponential equations and then apply what we call a change of base formula to solve exponential equations. Before starting some examples on exponential equations, I'd like to give you a little overview of some of the skills we're going to be tapping into. We'll be lowering the base of the exponent to solve. Change of base formula will be incorporated. And we're going to see some special logarithm values being used. We are going to need our calculators, so if you don't have yours handy, press that pause key and go find your calculator so you can follow along with the examples we'll be doing today. In our first example of exponential equations, 4 to the 3x equals 8 to the x plus 1, we're going to incorporate a skill where we find the same base. So before we even think about solving this problem, we're going to think of a number that the 4 and the 8 can be lowered to so that they have bases that match. I hope that you're thinking that the 4 and the 8 can be lowered to a number 2. So 4 can be expressed as base 2 to the second, and 8 can be expressed as base 2 to the third. Very important that you don't forget about the other items in this problem, like the term 3x, and how about that x plus 1? And let's use parentheses since both of those terms have to multiply the 3. So we have that, and now what do you think we should do next? Maybe you're familiar and you remember with, we have to drop these bases, and when we drop them, what we'll do is we will set the exponents against each other. So I'm going to create an equation with the exponents. So 2 times the 3x equals 3 times the x plus 1. And again, this should be a pretty easy one for you because we've done problems similar to this in our previous assignments. So 2 times 3 gives me 6x, and that was pretty easy. But I find in the next problem, part of this problem, where we go to distribute, that many students forget to distribute that 3 to the 1. So be aware of that and make sure you get that in your notes, that we want to distribute to everything inside. Now that we have that, the rest is easy. We're going to subtract 3x from both sides and get 3x equals 3. Divide by 3 and x equals 1. Now I would like for you to take on the challenge of trying a problem like example 1 on your own. Go ahead and do this. You try. Come on back when you're finished and I'll have the answer for you. Okay, so did you get the answer of 1/2? If you did, to get the job done for example 2, we're going to need to incorporate two skills. We're going to need the special log values and the change of base formula. Now I have a question for you before we go to this problem. The question is this. In example 2, do you know what two values the power must be between to achieve a value of 7? Here's what I'm asking you. I'm asking you 2 to what power would put me right before the 7? What value would make me less than 7? And I want to know if I say 2 to the what would put me just slightly over the 7, so greater than 7. Do you know how to fill in those two boxes? 2, what value would you give this power? Maybe 2 squared, because that would give you a 4. And then what would you put in the second box? I'm thinking 2 to the third would give you a value of 8. So in order for me to get a value that puts the 7 in the middle, I would put 4 is less than 7, which is less than 8, meaning that I know the value of x must be between the 2 and the 3. Do you know where the 2 and the 3 just came from just now? They are representing the value of the power. And remember, logs find powers. So our job is to find the value of x that would equal 7. So I know that my value of x better be 2 point something. I'm even going to take it a step further and say, what do you think it's going to be close to? Take a guess. Do you think it'd be like 2.3, 2.1, 2.8? Well, since this 8 is real darn close to the value we want, which is 7, I'm going to hang closer to that 3. And if I were taking a logical guess, I'm going to say this might be like 2.7 or 2.8. So let's see exactly what the value of x will be. Logs are going to help us find this answer. A little something we're going to do that's different here is we're going to add something to this problem. So we're going to go ahead and take the word log and we're going to find a base and we're going to add to the problem. So here's what I mean by that. Let's get started. I'm going to write the word log. I have to come up with the base. I'm going to add log on the other side, come up with the same base. Remember, whatever I do to one side, I do to the other. We're going to go ahead and follow the rules of equations. And I have the 2x, that was the original part of the problem. And I also have the 7, that was the original part of the problem. I'm wondering if you can help me figure out what base I want to make this that will incorporate a special log values that will allow the 2 to drop out of the problem. If you're thinking 2, you would be correct. Whatever I do to one side, I do to the other. Now watch what we have here. We have a special log rule here. So this drops out of the problem, and I'm left with what? I'm left with the x. You cannot drop this log out of the problem because the 2 and the 7 do not match. So we're going to keep that in play. And that's okay. Because now if you look right here, we can go ahead and incorporate the change of base formula. So I'd like you to make a note that the first thing we did was to find or incorporate the special log value rule, and that was to find a base that matched the base of the exponent. So the base of the log was matching the base of the exponent. Go ahead and make a note of that. So we've got those to match, and now I'm going to incorporate the change of base formula. So it looks like this. X now equals, remember what we have to do, that little base of 2 is going to drop to the denominator, and the big 7 is going to stay in the numerator. So all we have to do is put a log 7 over a log 2. And then we're going to go ahead and use our calculator. We know how to do that, but just as a reminder, all you have to do here is go ahead and press log 7 on your calculator, the division key, and log 2, and you're going to get an answer of approximately 2.807354. And we have to round to the nearest thousands, so the 3 will make that stay the same, and so our answer is 2.807. That is our final answer. So how did we do? Did we come close to our estimation of thinking that that number would be somewhere around 2.7 or 2.8? I think we did a great job. So that's what logs do for us. They find the value of the exponent, and look at how technical we can get just by going ahead and using some log functions here. All right, I hope you're up for the challenge of this next You Try. I know that that problem that I just did might be a little tricky for you, so it's important for you to give this You Try a chance. And I'm going to throw you a hint if you do get stuck on this. So go ahead and press that pause key and give it a try. Come on back if you're not sure what to do and I'll give you a hint. Alright, so if you came back to me, you're looking for some ideas of how to come up with the answer to this problem. And it would be that I want to try to match this 4. So I'm going to put a log to both sides of the equation, and I'm going to get one that will match that 4 so that we can get a rule here that will allow us to remove the log from one side of the equation. So when you get these to match, the whole thing's going to drop out. Remember, whatever you do to one side, you have to do to the other. So that's your hint on that one. See if you can finish it off. When you're done, come on back and I'll reveal the answer. So the answer is approximately 1.953. Remember, you're rounding to the nearest thousandth, which is 3 decimal places to the right. If you got that right, alright, we're going to finish up with this final example here, and it will be example 3, 10 to the 2x minus 3 plus 4 equals 21. We are going to be incorporating the special log value idea again, just like we did in example 2. What do we need to do here first? Well, we want to isolate the x. So in order to do that, we're going to have to get rid of that positive 4 with a negative 4, and that will leave me with 10 to the 2x minus 3 equals 17. Now I want to get rid of this 10 here. It's in the way of me getting to that x. In order to do that, you probably already guessed it, I need to put a log base 10 on both sides of the equation. So when I add that log base 10 on both sides of the equation, I'm going to drop out those values there, and it's going to leave me with 2x minus 3 equals log 17. Now why didn't I write that 10? Well, it's a common log, so I don't need to, right? And I still have to get x by itself, so I'm going to add 3 to both sides. So 2x equals log 17 plus 3. And finally, I need to get rid of the 2, so I'm going to divide out that 2. So I'm trying to evaluate log 17 plus 3, all of that divided by 2. Notice I said all of that. That means I'm going to have to use parentheses here to protect that numerator. So I'm going to bring up a calculator here and show you how we're going to do this. Follow along with your calculator too. So we're going to start with log, but before I do that, I'm going to protect the numerator by opening up with parentheses. So opening parentheses, log, and only the 17 holds to the log value. So I'm going to have to close that off so that that 3 doesn't try to sneak in on the log value. Very important there what I just said. We're going to add 3, and then we're going to close the parentheses again because that set of parentheses will now close the value of the numerator. I'm going to divide by 2, press enter, and I get approximately 2.115224461. I'm going to round to the nearest thousandths, so my final answer is going to be approximately 2.115. Here comes your final You Try. Go ahead and see how you handle this problem. Come on back when you're finished. I'll have the answer for you. Alright, so what are you thinking here? Are you thinking approximately a negative 0.514? Wrapping things up here, here's 3 scenarios to consider. Perhaps you want to bring it to the same base. Maybe you want to use the change of base formula, or even create a special log value.